Hi, today I'm going to be talking of an important concept called adaptive gating in LLMs for better reasoning. In actual scenario, what we've seen in one of the implementation in, for our clients in the legal industry, the ask was they wanted a higher reasoning accuracy. Now, we wasted a couple of sprints trying to figure out existing methods, everything from RAG to knowledge graph to reinforced learning to judge-based LLM models into the pipeline to improve reasoning, but that really didn't help. So what really helped is like we did a bit of research and we went back to what was implemented in the older tech to see if the same thing can be used in the newer tech. Now, typically, what we are actually getting to is like if you worked on deep neural nets and specifically deep neural nets, which are multimodal in nature. So, multimodals, they basically allow for multiple inputs or multiple modalities of inputs, everything from text, video, etc., so and so. Now, in situations like that, the deep neural net is built with the ability to take multiple inputs and also have multiple outputs. Now, having said, you could have a potential architecture whereby you could feed certain inputs at the beginning and certain inputs at a later stage. So in this case, in the earlier layers, you may actually kind of go ahead and feed the initial inputs, and maybe at a later layer, you could actually go ahead and feed the secondary inputs. Now, what's the advantage of the secondary input is basically, the initial input would have actually gone through the processing of multiple layers in the beginning. And typically, what we're seeing is that the features identified at the later layers are more evolved and they are more well defined. So, at that point of time, introducing more information can be beneficial for the overall accuracy and the output standpoint of view. And now, what we've done in this case, typically, obviously, the input can be secondary input can be bidirectional by nature. In the sense, you could read the values of the later layers, and then based on that, you could actually provide an input, which is more suited for it to kind of get to that this thing. So you could throw in a classifier, you could throw in a knowledge graph or documents. That kind of helps, a lot in terms of trying to get the accuracy of the model to a better level. Now, taking the same concept, what we did is basically we did the same thing. In our case, we were using a fine-tuned model. So let's say I want to, in this example, I've kind of given Llama 3.1. Now, in this case, the Llama 3.1 is basically, it's about 32 layers or 32 transformers stacked back to back. And what we did as the initial test run, basically the initial primary prompt, which was actually sent to Llama 3.1, was a standard prompt which is a given. Now, and at a later layer, what we actually did at layer 23 and the layer 23 and layer 32, and maybe at layer 20, we decided to read the values of the output of layer 20, and then based on that we kind of applied that to a knowledge graph so as to basically retrieve certain data and then kind of feed at a later layer. So what the advantage what we've seen is that the output what we started getting from a reasoning standpoint, it was much better because this kind of resulted at adaptive reasoning at inference time. And the model was better grounded. We saw less hallucination, higher accuracy, and more controllable decision. Now, obviously, this throws open a plethora of architectural discussion that, hey, look, maybe at the layer 20, when we're reading the value, and a layer 23, when we are kind of, putting that secondary feedback into the system, we could do a lot more stuff. We could throw in an additional set of networks to basically do certain additional job or read additional data and then kind of feed that data back in order to make sure that basically the accuracy of the overall model kind of improves. Now, this is something which can be tried on, if you have your own LLM. Apparently, if you're using publicly, available, API for LLMs, you couldn't basically kind of do something of this nature. But having said that, I think it would be a nice thing for even publicly available, LLMs to actually have, the API call with the initial input of callback which kind of gives the output at a certain layer, and basically another API which kind of feeds data as a secondary input. Now that can help you in terms of looking at the whole architecture space from a drag and knowledge graph and in-context learning standpoint of a lot differently. And we've seen this benefited, for smaller models because we tried, mid-range models and they were doing pretty well. in terms of an accuracy compared to what we've seen. But having said, this entire the whole idea in terms of basically where you can actually inject into the layer 20 and you can read at layer 16 and then basically have relevant data back passed out into the processor, the secondary feed, it does have an improved answer. Now, having said, if you have any comments, feedback, feel free to reach out to me at my email, which has been provided, and my LinkedIn is this. Thank you very much.